Hello everyone, welcome back to the channel. In this video, we will deploy our Node.js REST API in AWS ECS Fargate with a fully scalable and secure architecture, where we will see that scaling the microservices with AWS ECS Fargate and RDS. So we will be setting up VPC, ECS Fargate, and load balancer, eSIM certificate, RDS, which will be the Postgres, auto scaling Route 53, and much more. By the end of this tutorial, you will have a production ready Node.js API running in AWS Fargate. So let's dive in. So if we see overview of the architecture, it follows the well architect framework, ensuring the security with the WAF and the KMS, IAM and the secret manager. So we will be creating the load balancer on top of it. We will be implementing the WAF. For the scalability, we will using the ECS Fargate with the auto scaling, and for the high availability we are creating the two zones, and for the observability we are creating the AWS CloudWatch from where we can see the logs, and we also do the configuration of AWS config and the CloudTrail. And if we see from the perspective of the user and the traffic routing, so user access the application via the custom domain, which is the managed in the Route 53. Health check ensure that the load balancer only route traffic to the healthy services. And for the security, we will be using the WAF for the protect against the malicious traffic, and also we are using the ACM for enabling the HTTPS with the SSL TLS encryption. And then we are using the application load balancer, which distributes incoming traffic across the multiple ECS Fargate tasks. And as we know already that we are using the Fargate, so we are using the capacity provider with the Fargate Spot plus Fargate, which optimize the cost by using the Spot instances for the non-critical workloads. And then if we deep dive on the network infrastructure, so we are creating the VPC setup with the network isolation. So we will be creating the three subnets: public subnets, app subnet and database subnet. So app subnet will be the private, which will have the internet access via the NAT gateway, and then we have the database subnet, which don't have the internet. And we are also getting the Postgres RDS with the master replica setup for the failover. And then we have the VPC endpoints, which allow the private connectivity without going to the internet. And then we also going to create the ECS with the tar definition, where we going to specify the CPU and memory limits, the ECR and our the CloudWatch configuration. And then we will configure the auto scaling. The best, and I can say the best and the other thing we are going to implement, which is the circuit breaker. So breaker will ensure the rolling updates and prevents the broken deployments for affecting the live services, which will be going to see in our demo. And everything we will be placing the KMS. And then for the security and compliance, we are using the AWS config, which will track the changes in the infrastructure. Then we have the CloudTrail, which logs the API activity for the auditing. And then we have a secret manager, which store the database credential and the API keys. And the key benefits of this architecture, this will be the highly available with the multi-agent setup for ECS and DB, and we are securing with the WAF, KMS, IAM and the secret manager. And on the point of scalable, we will using the auto scaling Fargate task, and for the cost optimization we will using the Fargate Spot, and for the Observe Observability, we are using the CloudWatch and the Matrix. So this is Node.js REST API running on the Express.js, which includes the Swagger API documentation and the Prometheus monitoring. And here you can see that here I'm using the API endpoints. If I do /API hyphen docs, you can see that this will open the Swagger documentation, and if we do /ping, it will return the welcome message. So let's start with the creation of the VPC first. uh, we will create a VPC with the three types of the subnets: a public subnet, private subnet, and database subnet. So let's go to the option called your VPC, and we will going to create the subnet to across AZs to ensure the fault tolerance. And in the public subnet, we will host the application load balancer. In the app subnet, we will going to place our ECS Fargate task, and in the database subnet, we are going to place the uh, RDS Postgres. Okay, so let's go to the create VPC, then give a name called ECS Fargate VPC with the CIDR block of 10.0 slash 16, which will having the 65,000 around IPs. Then let's go to the subnets. Let create the subnet first. Let's give a name, public AZ1. We will choose it. We will 10.0.1.0 slash 24. Then we will going to create another subnet, which will be the public AZ2, which we are going to place in AP South 1B. Then have 2.0.24. Then we are going to create another subnet, which will be the app subnet. We can say app private AZ1. Then we have the, let's choose the 10.0.3.0 slash 24. Let's copy this name and create the another subnet inside the on the AZ2 South 1B 10 3.4.0/24, and then we will create two more subnets for our database, and we can give a name called database AZ1, and here we will choose 10.0.5.0/16, and then we will 10.0./24, and then we are going to create last subnet, which will be the our database AZ2 on the episode B 10.0.6.0/24. So let's filter out with the VPC. Yeah, so we are having the two public subnet, two app subnet, two database subnets. Now we will be setting up the internet gateway for the public subnets. Let's go to the internet gateway. Let's create it. Let's give a name called ECS IDW. Then attach to the VPC. Now let's create the one route table. Let's give the name ECS Fargate public route table. Let's give a short name RB. Let's to create route table. Let's select the VPC name, create route table. Let's edit routes, add it here, internet gateway. For the internet access for the subnets, let's add the subnet association here. Let's go. Then let's go to the route table again. So we will be creating the another route table for our for the app route table ECS. What naming convention we have followed? ECS Fargate. ECS Fargate app RB. Let's create it. Route table. Go to the subnet association. Let's do save association, and then we going to create the third route table, which is our ECS Fargate DBRB inside the ECS Fargate VPC. RD subnet association, then we will choose database as even. So now till now we have created the one VPC, two public subnet, two private subnet, and two database subnet. Internet gateway attached, route tables are configured, and now we will jump into the ECS cluster creation. Before creating the ECS, I believe we need to first create the ECR, which we will use in our creation of the tar definition. Okay, so let's first create in the ECR repository. Let's go to the ECR service and let's create the repository. Let's give a name called Node.js API, and then scan on push, enable it. Let's do create, and then if we click here we see the push command. So first of all we need to authenticate it, right? So before pushing images, Docker need an authentication with our ECR. So let's copy this one and go here and copy this one. I don't have the Docker, I have the Podman on my local laptop. So you see that we are able to log it succeed. After the successful login, we are going to build the Docker image for our application. And before that, please clone this repository on your local laptop to build the Docker image. So already I have the code on my local laptop. Let's build the Docker image. Let's give the podman build -t node.js -API. So -t stands for the tag, and dot stands mean that my Docker file resides on that root directory. Okay. So let's just wait for a few seconds, and after that we'll verify our Docker image. Now we can see that our Docker image has been successfully has been created. Let's do the podman images. We can see it's been created. Okay, now let's go to the ECR. Now copy this command and we will replace the value. So we need to tag the image. Let's do all the things remain same and just do podman. If you have the Docker, then go with the Docker. Then do copy this one and then go here and push. So I think, sorry, my bad. Let me copy this one, then do podman push. It will take a few seconds to upload the Docker image to the ECR. Let's wait for it. Now we can see that our image has been pushed to ECR. Let's confirm it from here. Let's go to the repository. Now we can see that we have the latest tag image. Okay, and now here we will see that whatever we have the vulnerabilities, because at the time of the repository creation we have enabled the scanning. Okay, let's go into the next step and we talk about uh, our currently we have created the ECR repository, we have created the VPC. Now we are going to create the database. Let's go to the database. Let's start with the database creation. Let's go to the left hand side, choose databases, and let's click on the create database. Okay, so let's before that let's do one thing. Let's create the first subnet groups which we will going to use in our RDS creation. Okay, let's go to ECS DB subnet. Okay, let's copy this name as description. Let's choose our VPC. Let's choose availability zone. Let's choose the database subnet. Now we can see that ECS DB subnet has been created, and now also let's create the one security group inside this VPC, which we will going to use in our RDS instance. Okay, let's give this name ECS Fargate DBSG, and then with this one let's choose the VPC. Let's open the Postgres port, which is 5432, and let's allow the our VPC side. Let's click on the create DB. Let's give a name called database. Let's copy this name. Let's click on the create security group. Now let's jump into the RDS creation. So while creating the database, you will get the two options, which is the standard create and the easy create. So I believe in the easy create option you will not get the multi easy. So let's keep as it is. Let's go with the standard create. Let's choose the PostgreSQL. Then let's choose, then we will have three templates, which will be the free tier, dev and test and production. So if you need the multi easy, then go with the production or any other things. Means if you need the performance, then go with the production, but for the demo purpose we will go into the dev and test. Now if we go back to our diagram, you can see that we have the one master which is on zone A, and we have that become the zone B. But for the demo purpose, if you want to set up like this, then choose the multi-easy. Then otherwise just go with the single DB instance. Okay, let's give a name called ECS ECS Fargate DB, and then give the master username, which is the Postgres. And I think for the best practice you can use secret manager, where you can store the RDS credentials. Okay, but for now we will using the our self manage. Let's keep the simple just keep the password simple, admin 1 2 3 4 5 6, and let's do admin 1 2 3 4 5 6. Okay, then in the instance configuration, let's choose the T series. Then same, we don't need that much storage. Let's do, I think, yeah, sorry, forget that. Minimum we need to provide 20. Then let's choose the VPC. Then already we have created subnet, and let's already we have the subnet group, right? If we uh, if we here if we go here, we can see that PC, right? Then not this one, I think. Let's filter out the security group. Or let's create the new one. Okay, 01. Let's do 8, and we will use the default port, which is our the 543 port number. And then we don't need the performance insights, and we don't need the NS monitoring. um, for the database name, we can give the uh, node.js db, and we don't need the automated backups. Yeah, we need the encryption, so we have done it. And let's do the status keep as it is. Let's click on the create database, and I will pause this video and we'll get back when the instance successfully created. Now our database has been successfully up and running. Let's go here, and let's, yeah, all the things are there. Let's go to the security group. We can change it further and modify as well, but still I wanted to see. If I go here, let's check the inbound. So let's do one thing. Let's keep as it is. Later on we will restrict it our only we will restrict it via the app security group, but for now let's give it save it. Okay, now let's go. If we go to the diagram, then we can see that our database has been created, VPC has been created, and an ECI has been created. Now let's go and check the Route 53 things. Okay, let's move it to the Route 53 zone. So for this we need to register a domain, which already I bought from the hostinger. So if you haven't purchased this, you can purchase from there, or you can purchase from the uh, AWS as well. Okay, by going to the register domain. Okay, but already I have purchased this, so let's go with the option called hosted zone. Let's create the one hosted zone called code devops dot site. Let copy this description, let's keep as it is, and this type will be the public hosted zone. So you can see after the creation of this, we will get the some uh, name servers. Copy the name servers, and you need to update them in your domain registrar. Okay, so if I go here, you can see already I have this domain purchased from the hostinger. Let's click on the chain name servers. Let's copy here. Let's move the dot. Let's click on save. And you can also create the hosted zone via the AWS CLI as well. Okay, now we will be going to create the ASIM certificate. Let's search for that. Let's click on the request. Let's call the code devops.site, and we will also take the, for the subdomains we will take star dot code devops.site. Okay, let's things keep as it is. Let's click on the request. Yeah, so let's do create. uh, it will take like 24 hours, or sometime it takes a time if you have done some misconfiguration. Otherwise it will be validated in the 15 or the 20 minutes. So let's wait for this. I will get back when my ACM certificates has been active. Now the SSL certificate has already been validated and available in ACM. So let's start. And also one thing I wanted to update here, that I have updated this diagram. I have removed the VPC endpoint, and as far I think that VPC endpoint is not needed, so I have updated the diagram. Okay, so everything has been created. Let's jump into the load balancer part. Let's go to the EC2. Let's commit to the target group. So target group is needed wherever the ECS task will be registered. So let's create the target group. Let's choose IP address and let's give a name ECS Fargate TG, and our container port is 8080. Okay, let's choose the VPC called ECS Fargate VPC, and let's keep the settings all default. Let's click on the next, then remove this part. And as you know that currently we haven't created any cluster, so that's why our we don't have any targets. Let's click on the create target, and everything you can see that we have the zero healthy, and because nothing is attached it, right? So let's go to the load balancer side, and we are creating the application load balancer. So ECS Fargate ALB, and this will be the internet facing. Let's choose ECS Fargate VPC, and let's choose the public subnets, and let's let them create the VPC, and we will choose the HTTPS. Okay, and here we choose the target group, because our traffic, whatever the user is giving the request, so it will the SSL will offload on our load balancer level. So that's why I've taken the listener on 443, and then it will forward to our target group. Okay, then from ECM, let's choose our ECM certificate, and here we are implementing the WAF. So currently we will be using the predefined WAF, which will block it, and then just review it and just do create load balancer. So after successfully creation, it will take a few seconds to provisioning it. Now we can see that our load balancer has been successfully provisioned, and it is on the active state. Now let's moving forward. Let's go to the our last part, which is our ECS Fargate, which is the core heart of our agenda. Like we are going to create the ECS cluster, which will be the Fargate. Okay, so let's go here. Let's search for the ECS. Let's create the ECS Fargate cluster. So on the left hand side, click on the cluster, create cluster, and let's give name ECS Fargate cluster. and let's definitely we'll be going with the AWS Fargate, which will be the pay as you go. So moving forward, that we can also we will going to enable the container insights. It will give us, it will give the more benefit, like we can track the status of the ECS task, we can collect the resource usage metrics, and we can also count the running services and the containers and many other benefits. And then we will also enable the encryption to encrypt our storage. And let's click on the K cluster. Now let's refresh this page. It will take few seconds to come the cluster up. Yeah, now we can see the now our cluster has been is created. Now let's go to the task definition. While the cluster is being created, now let's meanwhile we can create the task definition. Let's give the task definition name, which is a node.js -api task, and our launch type will be the AWS Fargate, and the operating system will be the same Linux. The task size we can reduce it. For now we can give 500 CPU and same as the 1 GB as memory. And this here you can see the task role we have to define. One is the task role, second is task execution role. So if we talked about the task role, so it is used for the manage application access to the AWS services, like from the inside container. If the container wants to access the S3, DynamoDB or RDS, then we have to give the permission to that IAM role. And then second we have the task execution role, which is the this role will be used by the ECS agent, like fetching the images from the ECR or logging to the CloudWatch. So already I have predefined IAM role. We can take this. I will also put the IAM policy in my blog. And then let's go here, then give this a name, Node.js API. And now we will go here and we'll copy our ECR URL. Okay, so let's go here, give the name, let's keep as it is. Our container is running on the HTTP port number, give it the name called HTTP. And later on, okay, now here we will see the things that going to specify the environment variable. So our container, if want to connect with the RDS, so if we go to the code side, you can see that here we have declared the environment variables. Okay, so let's copy the environment variables here: db host, db password, db username, db port, db name. And so you can see that there's a value and value type. So value type will, we can do the hard code here, and value form here you have to pass the secret manager ARN. So let's, for now let's keep as it is a plain text, and let's open the RDS and we will take the values from there. So meanwhile we can put the password like admin8123455, then db username called postgres, and db port was 543, 543, and db is node.js db. And the db host we can copy it from here. Let's go here, copy this, and on the configuration side we can configure, yeah, confirm the db name, so which is a db name. Okay, now we will also enable the log connection, which will send the logs of our container to the CloudWatch. Okay, then here you can use the storage, MFL storage. You can also use the add volume, and you can also monitor, means you can configure the application trace and send that matrix to the open telemetry. Okay, but for now we will keep as it is. Let's click on the create. Now we can see that our task definition has been created. From here we can see all the details of the task size and the task memory, container name, and all the properties of the container. Okay. Now the task has been successfully created. Let's deploy it and create the new service. Let's go down, and here you can see that already we can choose the cluster name, and here we can use the capacity provider. You can use the two capacity provider together, Fargate and Fargate Spot. This is a very good practice, you can say. Let's keep the both, and if we scroll down here we can give the service name, which is the node.js-svc. Let's keep it as a one, and if we can, let's keep as it is. And this is a very important thing, so that's why if you see my diagram here, you can see here I specify the circuit breaker. So it is very useful in the production upgrade. So it means that if the current deployment fails, the service will automatically roll back to the last completed deployment state. Okay, and that will be the very useful. And you can also use CloudWatch alarms. It will alert you that this rollback has been failed, but for now just keep as it is. Then if we go down, let's go on the networking part. Let's choose our ECS Fargate VPC, and we will choose the app subnet here, okay, which is the private subnets. Now let's remove the database subnets, and let's create the new security group. Okay, let's give a name ECS Fargate app SG, and for now let's open the port 80, and uh, let's for now we will use this one, but later on definitely we will I will also share you the advanced section, like where we will restrict this value from the load balancer security group. Okay, then let's scroll down. Let's click on the use load balancer, and here you can see the container which we have created, but here we will use our existing load balancer which we have created uh, before, which is the ECS Fargate LB, and here we are going to use our 443 listener and the target group which we have created earlier. Okay, let's scroll down, and here we will do service auto scaling. Let's give the minimum number of tasks the 1, and here as it is 10. And for the target scaling we can give a CPU. Let's take target value 70, and let's click on the create. Now it will take few seconds to things everything comes up, and in the meanwhile let's go to the route 53 and create the one record here called uh, app.code site, and let's choose the alias, and here we will choose application load balancer Mumbai, and let's create record. And if I do here app.codedevops.cloud, and things will not work. Now let's troubleshoot it. Now we will create the VPC endpoint for the Amazon ECR. So in this case, we need to create the two endpoint. One is for the ECR API and second for the ECR to pull the Docker pull images. Okay, so let's give the name called ECS Fargate API. Let's choose ECR. Let's select this one. and choose the subnets, and we will choose the app subnet because our container lies on this subnet only. Let's go with the full subnet. Let's click on the create endpoint. Then you can see that our VPC law endpoint has been successfully created. Okay, then let's go with the creation of the another endpoint which is used for the Docker image. ECS Fargate, and let's type the ECR. Let's select this one, select the VPC. Let's do app subnet. Let's wait for this endpoint to be up and running. Now our all the endpoints are available. Let's verify it. Okay, VP security is correct. Okay, I think we have chosen the wrong security group. Let's take this one, and same for this Docker. Now let's go to the ECS and we'll be doing the deployment. Let's go here. Let's go to the task service. Let's wait for this. Now our status is active. Let's go to the task. Now it seems that our task is running, but they are failing due to some other error. So let's click here, and seeing the error that unable to pull secrets, the task cannot pull registry from the Amazon ECR. So let's troubleshoot that error, and I have found that I think we also need to create the S3 gateway endpoint as well. Okay, so let's go to the VPC again and create endpoint ECS Fargate S3. Let's do S3. Let's choose the VPC, and let's make the app route table. Let's click on the create endpoint. Okay, now it's available. Now let's do the force new deployment. It will take some time. Let me pause this video and I will come back again. So let's troubleshoot that error, and I have found that I think we also need to create the S3 gateway endpoint as well. Okay, so let's go to the VPC again and create endpoint ECS Fargate S3. Let's do S3. Let's choose the VPC, and let's make the app route table. Let's click on the create endpoint. Okay, now it's available. Now let's do the force new deployment. It will take some time. Let me pause this video and I will come back again. So the task was also showing the same error. So I recreated the ECR repository with the private endpoint, and after that it started working. So I will provide the necessary commands on the Medium page as it won't work directly. So I will just give you the walkthrough. So whenever you will go to your VPC endpoint, So for the API one, you have to click here, and into the action you have to enable this private DNS. Okay, and after that you have to copy this one, and I will provide you the command from where you can create the ESR repository. Okay, so before that, let me try to run this app code devops.site. We can see it is working fine. Then do slash ping, that is also working. Okay, and if I do slash metrics, it's working now. The last part is pending is our to create the health check. So let's go to the route 53, and in the left section you can see create health check. So let's go here and let's click on the create health check. Let's give the name called app code devops health check, and here you have to provide the domain name, which is our we can give www dot code app dot code devops dot site, and we can also give slash ping as well. Okay, and here we can give the protocol. Already we have given this, and let's make this git health check. So it's enabled. It seems that our status got failed. Let's go here and remove the www. Let's remove this one. Now let's do save. And it's up to us whether you want to give slash ping or you want to just give your website domain name. And also you can set the alarm based. Okay, like you have to go here, and you can also uh, create the alert that if it get down, you should get the alert. Okay, so from here you can configure it. So let's go over again, and if we see that every part we have completed, let's discuss about this main part, which is our AWS config. So let's go over there. So AWS config is a service uh, which automatically which will that automatically monitors and evaluate AWS resources against the best practices. Okay, so it will track the changes and ensure that your security policies are enforced. Okay, so suppose we have here. Okay, let's go to the view dashboard. Okay, let's come to the rule side. Okay, let's create one rule, and let's do the WAF. Okay, so this is the rule. It will say that it will check whether the WAF is enabled on the application load balancer or not. And I think this is a very best practice that WAF should be enabled on the ALB, uh, so that it can help you from the malicious activities. Okay, so let's check here. Let's click on the next side, and it will check all the AWS all the load balancer in this region. Okay, let's click on the next. Let's save. Okay, and after that we can see we will see the dashboard, that which are compliance or which not. And then you can create the another manage rule as well. You can create the custom rule as well. So in this way we can create it. So let's go back, and now we can see that our status got healthy. And from the metrics section we can also see from the past 1 hours it seems that no endpoint is the healthy from the past 5 minutes. Okay, so thank you so much for watching, and if you enjoyed this video please give it a thumbs up and subscribe to my channel for more great content. and don't forget to hit the bell icon to get notified whenever I post a new video. See you in the next one.